Okay, today we'll be going through the January 2021 Physics Unit 1 paper. Okay, so I'm just going to go through section A, the multiple choice, and explain what the answers are for each one. Okay, so as you can see, question 1, so we have a car which is moving towards a stop sign at speed of 25 meters per second, and then the driver applies his brakes with 20 meters before the sign, and it decelerates uniformly to rest just before the sign. Okay, whenever we do these types of questions, we need to understand the information that's given to us. So first of all, we know that it's initially a speed of 25. The driver applies the brakes at 20 meters, and it comes to rest. Okay, so we need to write down everything we need to know. So initial speed, that's going to be 25. So our U is going to be 25. Okay, at S, the distance it travels in that deceleration period, that's going to be 20 meters, and it comes to rest. So that tells us that our final velocity is going to be 0. And they want us to find the acceleration A. Okay, so we first of all identify everything we know about the question. Knowing these values, we can use our Subert equations. So we don't need to know t. So the only equation that doesn't have t is the v squared is equal to u squared plus 2as. Right, just rearranging for deceleration. So we get v squared minus u squared over 2s, that will give you our acceleration, right? We just have to plug it in. So v is 0, so 0 squared minus u, which is 25 squared, over 2 times the distance, or displacement, which is 20. That will give us our acceleration. So our acceleration is equal to minus 25 squared over 40. However, note that they want us to find a deceleration, right? That's why we have the negative value. So the deceleration value would be when minus a is equal to positive 25 squared over 40. So that will be our answer for C. Right, question 2. So we have an object of mass 8.2 kilograms, once again circling what we do know, which is initially at rest, and it falls a vertical distance of 25 meters through the air, and has a final velocity of 20 meters per second. Which of the following gives the energy in joules dissipated by air resistance? We know that the air resistance is going to take away or take out from the energy change. Okay, so we know that it's going to fall a certain distance, which means it's going to lose GPE, gravitational potential energy. So how much GP does it lose? Well, it falls a distance of 25 meters. So we know GP is equal to mgh. So the mass is 8.2. and the g is 9.81, and it falls a distance of a height of 25 meters. So this is the total energy that is lost as the ball falls. This energy is now transferred into kinetic energy. It's going to gain kinetic energy, right? So the kinetic energy equation is equal to half mv squared. So that's going to be equal to 1 over 2 times the mass, which is still 8.2, times the velocity. It goes from 0 to 20 meters, so it's going to be 20 squared. So this is the loss in GPE. It's going to go into the gaining kinetic energy and the energy dissipated by air resistance. So the difference between these two, GPE minus kinetic energy, will give us the energy, will give us the energy dissipated by air resistance. So therefore it will be C. Alright, moving on to question 3. Okay, so we have a graph which shows how the acceleration of an object varies with time. So it's an acceleration time graph, and they want us to find the velocity time graph. First of all, we need to know, how do we relate acceleration and velocity? Well, we know acceleration is the rate of change of velocity with respect to time, dv by dt. So from this velocity time graph, we know that the gradient would be equal to the acceleration. Okay, let's identify what's happening to this object. So as you can see, as time increases, the acceleration is increasing as well, but it's increasing at a decreasing rate, right? So what does that mean? Well, what happens to the gradient? Well, as the acceleration time is going, the velocity would also increase as well, right? It would increase, but how would it increase? Well, the acceleration is going to go to a bigger and bigger value as time goes by. So the velocity is going to change, or it's going to increase at a bigger rate, essentially. So that's why the answer is D. The acceleration is increasing, so therefore the velocity will increase at an increasing rate. So the gradient here, so the gradient here, well, that's going to increase as time goes. Okay. Question 4. So question 4 is using a student measures the time taken for a ball bearing to 4 different measured distances s from rest. He then wants to plot a graph with the gradient equal to the acceleration g. Alright, so once again, identifying what we know. The student is going to drop a ball a certain distance s. He drops it from rest. Okay, that means that u initially is 0. We're trying to find what a is, the acceleration. Okay, so the acceleration, that's what we're trying to find. Okay, and also he measures t. Okay, so he measures t. Using what we know now, what we have is we can use a Suvat equation. So we can say that s is equal to ut plus half at squared. Half at squared. Right? U is 0, so this reduces to 1 over 2 at squared. Okay, so we're trying to put a graph here, aren't we? So we want to make a the gradient. So we need to get rid of this 2. So I can say that 2s is equal to at squared. So I can plot a graph of 2s on the y-axis and t squared on the x-axis. And in that case, the gradient will give us a. Okay, so the answer will be B. Alright, let's look at question 5. So a student is investigating a material in the form of a wire. Which of the following properties of the wire would change if the longer wire is used? Alright, so let's look at each one individually. Breaking stress. Well, stress we know is equal to force over area, called technically cross-sectional area. So this is independent of length, so it's not going to be A. We also know that density, well, that doesn't depend upon the length of the wire, so it's not going to be B either. Right, C or D? D is the Young's modulus, and the Young's modulus is actually a constant depending upon each individual wire, or the material it's made out of. So if we keep it as the same material and just change the length, then this is going to be constant as well. So the answer will be C here. Okay, so let's take a look at question 6. So we have two objects which are traveling towards each other and then they collide. A has a mass of 2 kilograms and it's traveling at 3 meters per second. B has a mass of 5 kilograms and it's traveling at 2 meters per second. Alright, so what's the total momentum of A and B after the collision? Well, we know that momentum is conserved, so momentum before is equal to momentum afterwards. So all we need to do is find the total momentum before. So let's draw our situation here. A has a mass of 2 kilograms and is traveling to the right at a velocity of 3 meters per second. B has a mass of 5 kilograms and that's traveling to the left at the velocity of 2 meters per second. So using that momentum equation, P is mv. Okay, so we have 3 times 2 plus the mass is 5 of B times the velocity is 2, but it's to the left, so we make sure we write minus 2, like such. So we have 6 minus 10, so that's equal to minus 4 kilogram meters per second. Okay, we took going to the right as positive, so it's minus 4 means it's going to the left, so the answer will be A. Okay, question 7. The student determines the terminal velocity of a ball bearing as it falls through oil. He releases the ball at point V and measures the time taken for it to fall a measured distance. Which 2 points should be used to measure the distance? Okay, so he wants to work out the terminal velocity. Okay, terminal velocity is we know is when the maximum velocity, right? When the resultant force is equal to 0. We also know that it takes some time to reach this terminal velocity. So we need to understand what distance we need to measure. Well, V and Y. If we measure V and Y, well, that's not going to give us the terminal velocity because it's going to accelerate in this period here, right? So it's not going to give us a terminal velocity. We want to measure a distance probably further down, 2 points further down the tube, just to allow it to reach that terminal velocity point. So W and Y, well, W and Y, that's once again, that's a long enough distance. However, W is right below when it's just about to start to accelerate. So it probably hasn't reached that terminal velocity point yet when it's at W. X and Y is probably more suitable because by the time it's reached the X value, it's probably at its terminal velocity position. So the answer will be X and Y. Okay. Question 8. Which of the following is a vector quantity? We know vector quantities are values or anything that has a magnitude plus a direction. Okay. So density, well, density is a scalar or straight away. Energy is also a scalar. Viscosity is also a scalar. So the only vector quantity here will be momentum here. Because momentum is, remember, is mass times velocity. Velocity is also a vector quantity, which makes momentum a vector quantity. Question 9. Which of the following statements is not correct for Newton's third law pair of forces? Well, Newton's third law is every action has a reaction, right? In the opposite direction, okay, of equal magnitude. So first of all, act in opposite directions. Well, that's true, so that's not going to be A. C are the same type. Of course, they're the same type. What that means is if it's a pushing force, then there's also a pushing force, the pair. If it's a tension pulling force, then it's also a pulling force. So it's not going to be C. And they have the same magnitude, so it's not going to be D. So the answer will be B. Okay, the final question 10. A locomotive pulls a train at a constant speed against a force of 8,400 kilonewtons. The output power is 70 megawatts. Which of the following gives the time in seconds for the locomotive to pull the train a distance of 1 kilometer? Okay, so we have a lot of information there. Okay, so we have power. And we know that power is equal to the rate of change of energy, so it's energy over time. I can say the energy, or I can say that's equal to work done. So I can say it's equal to force times distance. That's the equation for work done over time. We know that distance over time is just velocity, so I can say that's equal to F times V. But we don't really need this second part here. So I have the equation that power is equal to force times distance over time. We want to get time, so rearranging for time, time is equal to force times distance over power. Okay, now we have the equation, we can just plug the values in. So T is equal to force, well, making it's 8,400, but it's kilonewtons, right? So that's going to be 8.4 times 10 to the 6 times the distance traveled, 1 kilometer, changing that into meters, 1 times 10 to the 3. And the power is 70 megawatts. Mega is 10 to the 6, right? So 70 times 10 to the 6. So this is equal to 7 times 10 to the 7. So the answer would be C. Okay, so that's all the section A part done of January 2021. And hopefully it's useful for you guys. I'll see you again next time.